Hello. How does independent probability work? And why are we multiplying stuff through trees? And when are we adding stuff through trees? Let's use this as a very simple example to work our way through, shall we? Okay. Question. We roll two dice, a red and a blue dice. What is the probability of rolling two sixes? Well, our basic approach relies on an assumption that this is a fair dice and therefore all the outcomes are equally likely. We can create a probability space. So the red dice has 6 outcomes, 1 to 6, and the blue dice has 6 outcomes. So we have a combined outcomes, which is a 6 by 6. Yep, we happy with that? It's a 6 by 6 here. What's the probability? How many of these outcomes are two sixes? So there's that one there and that one there. So that only creates in our table one outcome out of 36. So there's our 1 out of 36. That's our probability. As we can see here, we've got our 36 because it's a multiplication there, isn't it? 6 by 6. Okay. And there's only one of those there because that's 1 on this side times 1 on that side there, isn't it? So we've got our 1 times 1 on the top divided by 6 times 6. So we can see there that we've got a 1/6 times 1/6. And that's what we're going to look at in our probability tree, which is the other way presenting exactly the same data. So we roll our red dice and we've got a 1/6 chance of getting a 6. And we've got a 5/6 chance of not getting a 6. I'm just going to mark this up in blue actually because that will help us, won't it? And then we've got we roll it again, and again we get a 1/6 chance of getting a 6, and that means that going down this route here of getting two sixes, therefore the first one must be a 6 and the second one must be a 6. Hence we write 6 and 6. And what we're going to do with these two probabilities, 1/6 and 1/6, well, we're going to multiply them together to get 1 over 36. What's the alternate? Getting no sixes. Well, there's a 5/6 here on this route of getting the first one's not being a 6 and 5/6 on the second one not being a 6. Well, how does that connect with our sample space? Well, not getting a 6 is the whole of this section of the red and the whole of that section of the blue. So every one of these is not get a 6. How many in there? Well, that's 5 times 5, isn't there? In there, out of our total, which is still 36. So what a surprise. Our probability here is 5/6 times 5/6, which gives us 25 over 36. So that's our fundamental idea. So what have we found out then? That when we use the term and, so we got a 6 and a 6, we're going to multiply in these independent problems. Okay. When do we get an addition? Okay. We roll. Let's use exactly the same 2 dice roll, but this time what's the probability of rolling 1/6? Okay, so if we look at our probability space, our sample space, our outcomes where we get 1/6 are all of these ones here. In this area, there's our 6. We can't have the bottom one because that would be 2 6s. So we can get a 6 on the blue and not on the red, or we can get a 6 on the red and not on the blue. So how many have we got here? We've got 5 of them there and we got 5 of them there. And what we're going to do, so we've got a total of 10, haven't we? Okay, so let's have a look at that in our probability tree method of modeling. So what are our routes here? Well, we could get a 6 on the first and not on the second. And what we're going to do with those two, we multiply them there, but we get 5/6 here, don't we? Or we could get not a 6 on the first and we get a 6 on the second, and we got 5/6 there. But all of these probabilities here have to add up to 1. and that is consistent with that we're going to add these two probabilities. Why? Because we could have a 6 and the not a 6, or we can get a not 6 and then a 6, and we're just adding these together. So our 5 6 plus our 5 6 gives us our 36, gives us our 10 36, which is what we had up here. There's our 10 here out of 36 options. Yeah, so what's that telling us in this world? Well, if we start going along a tree and we're saying the first probability and the second probability, maybe the third, maybe the fourth, but if we've got first and second, so it's probability A and B, then we're going to multiply them together. Probability of A times the probability of B. If when we get to some point going, rather than going, this one was going along our tree, wasn't it? If we get to a point where we're looking at an or, we're looking at a couple of outcomes, like here at the end, up and down our tree. So if we get to an or here, probability of A or B, then we're going to add them together rather than multiply them. And I think it's as simple as that. If you can keep that in mind, it will really help you. Bye then.